Review for Lab 2. So the idea of this review exercise is to help you understand a little more deeper what happened in each of the parts of the experiments that you guys run. So as you watch this video, the idea is that you print the worksheet and you write down the chemical equations for each part. So we're going to learn how to write chemical equations. Then you're going to use your lab notes to describe the physical characteristics of the reactants and the products. So if you saw bubbles forming, if you saw a liquid and what's the color of the liquid, so that way you can start making a connection between the visible signs of chemical changes and the chemical changes that took place. So in the first part, you guys grabbed solid iodine, and then we're going to use a subscript and an S to depict any solids. And then you applied heat to it, right? So you put it on the burner, and then you just heat it up. We're going to use a triangle. We use a triangle to depict the heat. So what you guys observed is that after you heat it up, the solid iodine started to form a gas. Now, what is the color of that gas? So use your observations to depict the color. So you're just going to write under your chemical equation, you're just going to write the color, for instance. You're just going to say, what was the color? And just write it over there, okay? And then what was the initial color also of this solid? Was it shiny? Was it metallic? Was it black, gray? What was the color? So I want you to start to write those observations based on the notes for your lab 2 report. Then, and that's pretty much what happened. Now, we also saw another change, that as we remove the heat, you saw some of that iodine coming back to being, going back to being a iodine solid, and you saw it, and that's just a very cool thing that iodine does. This process is called sublimation, and the sublimation pretty much just means that you have a solid that transforms or into a gas without going into a liquid state first. So it's pretty cool, and that's what you guys did on part B. Now let's look into part C. So you mixed aluminum, and the question is, what was it, right? So it was an aluminum solid, and you mixed it with a copper chloride solution. Now, we don't need you yet to really know how to come up with these chemical formulas. You will learn that later on in your chemistry class, but overall I'm just kind of jumping in and giving you the chemical formulas for these compounds. I'm not going deep into why it is the way it is. So in a chemical reaction, we depict the combining by using a plus sign. So it means that we combine copper chloride plus aluminum, right? So reacts with. This is a way you can interpret this as react with. So copper chloride reacts with aluminum, and then the arrow, you could read it as to produce. And then in this case, after this chemical reaction takes place, you saw the formation of copper solid and aluminum chloride aqueous. So how can a subscript that is used to depict the physical state of a reactant, it's the AQ, which means aqueous. And aqueous pretty much just means dissolved in water. So in water. There are very few, just water. It's pure water, pure a liquid. But everything else that you saw that had a liquid form to your eyes is actually aqueous, which is a mixture of whatever chemical you have. In this case, for instance, aluminum chloride with water. So we use the AQ subscript to depict that. So we're gonna use, so we have the copper chloride plus the aluminum, which is solid, and then the copper solid that formed with aluminum chloride. So now go to your notes and look at what were the colors. What were the initial color of the copper chloride? What was the initial physical characteristics of the aluminum? And how did the copper look like after the reaction? And what did the aluminum chloride looks like? What's the color of the solution? So it helps you to make that connection between this chemical equation and and the the chemical equation and the physical changes that the chemical changes that you guys observed in the lab. There is something else that is important when you write a chemical equation, and that is you need to balance. So we do not create matter, we only transform it. But I'm going to go ahead and balance the chemical equation. We will dig that into that later in the semester. So for now, I'm gonna write it because it's like spelling, it's the right way to do it. But we will just look deeper into that later on. So I have to level out my amount of chlorine, so I'm gonna actually use a coefficient of 2 over here, and then that gives me a total of 6 chlorine, and then I have my I'm gonna use a 3 over there to get 6 over chlorine there, which changes the amount of copper, and then I'm gonna have copper there, 3 copper, and then because of the 2 aluminum, I need a coefficient of 2 here. So this is just the right way to write the chemical equation, but we will later on learn how to do this. Now focus just on these physical changes, right? On these physical characteristics of the chemical changes. Now the next thing we want to do is mixing copper nitrate, copper with silver nitrate. So we reacted the silver nitrate, and the silver nitrate was in an aqueous, so silver nitrate aqueous, and you reacted that with solid copper, and then this produced copper nitrate and silver solid. So once again, make sure that you use these notes and so that you can write what the chemical changes were and those physical of things that you can observe that help you realize that there was a chemical change, and then how and let's just do that. Now we need to balance the chemical equation, and for that we're going to add a 2 here on the silver, and I already added the 2 there because of the 2 nitrates that we have there. Cool. So now let's move to the mixing zinc and hydrochloric acid. So hydrochloric acid is in an aqueous state. That's why it was in a liquid form when you used it in the lab. So we have HCl aqueous plus the zinc, and the zinc was metal. So it was actually these little pellets of zinc. And then that will produce zinc chloride, and hydrogen gas. Cool. Then the equation is it's balanced by adding a 2 over here. So remember, just under each of these, just write the color and any characteristic that you observed. So please be mindful that when you see bubbles as a result of a chemical reaction, it means that a gas was formed. So the bubbles represent that gas that was formed. And then for part F, we mixed lead nitrate. So that's PbNO3 plus potassium, or in addition to potassium iodine, and that reacted with and produces lead iodine, which is a solid, and the potassium nitrate, which is an aqueous. And this was aqueous and aqueous. So this type of chemical reaction is very peculiar because it's the mixture of two aqueous solutions, two liquids, to form a solid. And this is called a precipitation reaction. The magnesium strip. So it was a solid magnesium strip, and you put it on the flame. So what is important to realize there, and it's very different from the iodine when you're adding heat. In this case, when you put it on the flame, and it has to be on the flame for a long period of time, you're actually having the magnesium react with the oxygen in air, and then which is the oxygen gas, and it will only happen when it's it has to be high heat and the oxygen. And then with these guys, when they combine, they're gonna form the magnesium oxide, which was a solid too. And then we're gonna form 2 moles of this and 2 moles of this. So when we add heat and a chemical change takes place, in this case, when we're burning something, we actually have to have oxygen as one of the reactants. So just to recap, you have heard me use some words as reacts with. So the arrow, anything that is to the left side of the arrow, it's considered to be a reactant. And everything that is towards the right side of the arrow, it's considered to be a product. So the reactant, it's everything that you had before mixing, before mixing. So before the change took place. And the product is it's what you observe after you are looking at the changes taking place. So that you can kind of have a better idea of how to interpret the data that you guys collected. Now, when it comes to mixing mineral oil and food coloring. So all of this, we had water and we mixed mineral oil and food coloring, and we saw how it produced the mixture. We're not going to write a chemical equation for this because it is a mixture, it's not a chemical change. Now, this also should give you, what we just looked at, should give you an idea of which of these changes were chemical changes. So pretty much all were chemical changes, but the iodine and the mixing mineral oil and food coloring.